Dad, how did this get here? Didn't we just order it like a few hours ago?
When my older daughter asked that, I stopped for a second because it is a simple question with a surprisingly deep answer. Somewhere between a tap on a screen and a box on our doorstep, invisible systems spin up, data races across networks, decisions get made in milliseconds, and the physical world moves. It's fascinating to think what happens when you stream a song, book a hotel room, reserve a flight, or open an app and just expect it to work. All this technology is so fun, and I love working in this industry. I've spent my career building software and systems that make up the internet. I was CTO at Shopify and ServiceNow, an SVP at Slack, an early engineer at Cisco Systems, and now I'm CTO at Webflow. I've helped build data centers, protocols, software, and services, and led global teams along the way. This podcast is for anyone who wants to understand how our modern world actually works, not just shopping and delivery, but the invisible machinery behind nearly everything we do. It is for anyone who's ever wondered, how did this get here? Or how did that actually happen? I'm excited to take you on a journey, to take these layers of technology apart and explain them in a clear, grounded way. You probably think you connect to Wi-Fi, you're on the internet, and away you go. Well, I wish it was that simple. I'm Alan Meinwand, and welcome to Pixels to Packages. Hello, friends, and welcome to the second episode of Pixels to Packages. I'm Alan, and I'm glad you're here. Before we go any further, let's ground ourselves with a fast recap, because everything in this episode rides directly on what we talked about last time. In episode 1, we followed what happens the moment you tap a button on the screen, slowing that instant down a bit to see the machinery underneath it. Your browser began by using DNS, the domain name system, to translate a human-readable name, such as Google, into a numerical IP address that computers can actually route to. With that address in hand, the browser did not send one big message. Instead, it broke the request into many small packets, each one carrying a small fragment of the overall conversation. Those packets were wrapped inside multiple layers through encapsulation. Encapsulation, like nested envelopes, is where each layer, each wrapper around that packet has a specific job. Application data sits in the middle, surrounded by transport information from TCP, or the Transmission Control Protocol. Then the network information from IP, or the Internet Protocol. And finally, link level details that allow the data to move across a local network, such as Wi-Fi or fiber. Each layer added just enough to let the information move to the next system in the chain to do its part, to pass the packet along. The packets move from your laptop or your phone, over the Wi-Fi, through your home router, and out into the wider internet. And along the way, routers examined the IP information, one of those first encapsulation layers, on each packet and made an independent decision about where to send it to next. There is no single path guaranteed. Different packets from the same request could take different routes, cross different networks, and experience different types of network delay. TCP handles this uncertainty by tracking what was sent, what was arrived, and what needed to be resent, ensuring the connection between your device and the server across all those network hops in the data center was reliable, and everything was reassembled in the correct order. Eventually, those packets do reach a server in a data center. The server processes that request and generates a response, which again is broken into packets, encapsulated into those layers, and sent back across the network back to your home machine. The return trip followed the exact same path in reverse, although not exactly the same physical path. When the packets arrived back at your device, TCP put them back in order again. The browser unpacked the layers, and what you experienced as a simple tap resolved into data ready to be turned into pixels on your screen. That machinery, DNS, packets, IP, TCP, Wi-Fi, data centers, is all the foundation of Pixels to Packages. None of what we're about to talk about works without it, because episode 2 sits directly on top of episode 1. All of that happened so your device could receive some data in an application like a browser. So let's talk a bit about that data and what data the browser actually uses. When those packets arrive back at your browser and are reassembled, what the browser sees is not pixels. It sees code. It sees code in the form of HTML, CSS, and JavaScript. If you take nothing else away from this episode, take those three things. HTML, CSS, and JavaScript are the core building blocks of the web. HTML, or the hypertext markup language, defines the structure. It describes what exists on the page and how things are organized. Headings, paragraphs, images, buttons, links, containers. HTML answers the question of what is here and how it is nested on the screen. CSS, or cascading style sheets, defines presentation. It controls layout, spacing, colors, fonts, alignments, responsiveness. CSS answers the question, what does this look like and where does it go? And finally, JavaScript defines the behavior. It handles the interaction, motion, updates, and logic. JavaScript answers the question of what happens when something changes, when I click, when data arrives. That's what JavaScript's for. Inside the browser, JavaScript is actually executed by something called the JavaScript engine. It's a piece of software built into your browser. This highly optimized software, whose job it is to take JavaScript code and run it incredibly fast, is invisible, at least to you. In Chrome, that engine is called V8, and is one of the most sophisticated pieces of software that most people interact with every day without even knowing it exists. V8 takes JavaScript, which starts life as like readable text, words, characters you and I type, and compiles them into machine code that the CPU on your device can actually execute directly. It uses techniques like just-in-time compilation to squeeze out as much performance as possible, meaning as it's reading the text, it's compiling it down so the chips on your device, on your laptop or your phone, can execute them very, very efficiently. Now, different browsers use different engines, but the idea is pretty much the same across all of them. The engine manages memory, it handles the execution model, and it keeps the code responsive while still feeling instantaneous to you and me. Code comes in, behavior, execution comes out. And in between is an extraordinary amount of work that makes sure it all feels immediate, animations feel smooth, and entire applications can run inside of what looks like a simple web page. Now that engine runs inside of a sandbox. The JavaScript sandbox is so critical. It is a security boundary that limits what the website code is allowed to do. JavaScript running in your browser cannot run freely across your files, can't access memory on your device, it can't look at your pictures or your photos or other operating system details. It can only interact with the page and with carefully controlled APIs into the browser itself. And that is one of the reasons the web can be as open and as free as it is without being wildly unsafe. You don't want to have any random bits of code from any website you happen to hit come into your local machine and start executing and have access to everything. That would be incredibly unsafe. So that's what the sandbox is for. So now we have the structure, the style, behavior, and the security of how to execute that code. And all that software exists really for one thing, and that's rendering. Rendering is a process where the browser turns HTML, CSS, and JavaScript into pixels on your screen. And this is where things I hope really start to click. Because to understand rendering, you have to understand something else called the box model. And before we go any further, no, we're not talking about cardboard boxes. Not yet. We're going to get there. Those are coming later. This is a different type of box. And kind of like, the old it's turtles all the way down analogy. Yeah, it is boxes all the way down when you're looking at websites and browsers. Because every website is made up of boxes. Buttons are boxes. Menu bars at the top are boxes. Product listings that are arranged in grids. You can see the boxes there. They're boxes in a grid. Images are boxes, sometimes arranged in layouts that are easy to understand, sometimes in a masonry layout that looks like bricks, but they're boxes. Sliders are boxes that move. Animations are JavaScript updating boxes over time. Things that overlay or pop up or drop down are boxes stacked on top of other boxes. And once you see these boxes, you really can't unsee them. The browser's rendering engine uses the box model to lay everything out. Every element has a rectangular box. Inside is content, around that is padding, borders, margins that create spaces between the boxes. HTML defines which boxes exist and how they are nested. CSS defines their size, position, color, visual behavior, and style of things maybe inside the boxes, like a font, or a color of a font, or a padding of a font. JavaScript can change those boxes dynamically based upon the code that the script says to do. Now, you can see all this yourself. While I keep saying it's hidden and things you don't interact with, you can actually get there. In Chrome, you can view the page source to see the HTML, or open the developer tools and inspect the elements to see the boxes outlined directly on the page. It's under View, Developer Tool, View Source, and you can see it in there. In Edge, the tools are nearly identical. And when you do this and you actually look at the code, the illusion breaks. You break that fourth wall. You're looking at the actual structure the browser is rendering. You'll see things called divs and containers. They're boxes that hold other boxes. You'll see less than image, greater than image boxes that hold JPEGs or other image types like WebP or AVIS that are basically compressed image formats. A button is a box that responds to an interaction that puts another box on top for a drop-down menu. The rounded edges of things you see are boxes with curves on the edge. All this is not a metaphor. Boxes aren't metaphors of this. This is literally how the browser thinks. And remember, all of this code, HTML, CSS, JavaScript, was delivered for your browser from servers over the network we talked about last time. DNS resolved the name. TCP made the connection. IP routed the packets. Wi-Fi carried them to your device. A server in a data center responded. That code came back using the exact same path. The browser reassembled the data. The JavaScript engine ran the code. The rendering engine built the boxes. CSS styled those boxes. Pixels lit up. And again, all this happens astonishingly fast. Open Shopify or Spotify or Amazon or Google. And when you're looking at those pages, this entire chain we've been talking about is happening almost in real time. It's in milliseconds. Data is flowing. Code is executing. V8 engine is firing up, doing some compiling down to make sure that the code is executed efficiently. Boxes are being rendered. Content inside of boxes are being styled with CSS. Script inside those boxes are running to provide animation. Pixels are being painted. And here's the thing to hold on to. The boxes you see on your screen don't actually come from one place. I've been saying a server in a data center, but it's, again, just a bit more complicated than that, as you might imagine. So in the next episode, we're going to zoom back out and go deeper. We're going to talk about how this data actually comes from many different data sources. Servers are behind load balancers. Content delivery networks, or CDNs, provide content close to your house, close to your business, not all the way in the data center. And how does that information get distributed globally? Multiple servers and multiple data centers in different parts of the world might serve up different parts of content. Those images might come from somewhere different than the boxes representing the menu, than the boxes representing the colors or the fonts. All this is contributing pieces of HTML, CSS, and JavaScript, and that data that the browser pulls together into what you think is one beautiful web page with some really cool animations on it. Many servers, many networks, one page of boxes, but really one screen of pixels. Now, we still haven't even moved atoms yet. We haven't shipped anything. We're still firmly in the world of pixels. But we're getting closer to moving actual physical boxes, because you're eventually going to press a buy button. And when you press that buy button, that box, style with CSS, probably with some JavaScript behind it, things are going to move. And yes, that button is a box too, a box of pixels. Thank you for listening to episode 2 of Pixels and Packages. I hope you enjoyed it as much as I did. See you next time.